What we're going to do here is the final look at the eight queens problem that we've been using throughout the semester. What's going to be interesting is that the algorithm will be fundamentally the same, except the implementation is going to be using recursion. And it's going to turn out to be simpler than the way that we've done it before, because a lot of the bookkeeping will be handled automatically by the recursion. We'll see what we mean by that as we go along. But first, let me give you another example to help you orient the approach. So remember the basic idea of recursion. Like, how did I do n factorial? How did I do 5 factorial? I say I don't know how to do 5 factorial. But if I knew how to do 4 factorial, then I would just take 5 and multiply it by 4 factorial, and that's going to give me 5 factorial. So what we do is we say, I don't know how to solve the big problem, but if I can solve a smaller version of it, then I can solve the bigger one. So let's take another example. Let's have a string, a C string S, and it's terminated with a null character over here, right? So how do I print this? One way of printing it is to say the following. I don't know how to print a string of size whatever, right, of size n. But if I could somehow print a string, a smaller string, then I could print the whole thing. So to print S, I would just print the whole character, the first character, and then call the print function on the rest of the string, right? It's like 5 factorial. It's going to be 5, and then you call factorial on 4. So to print the whole string, print the first character, and then call print on the string that represents the rest of the string, right? Of course, as in all recursions, you have to make sure that there's a base case. The base case, in the case of a string, is if the string that you're given is just the null character, then you return. So here's a very simple, here's a simple program that does this, right? So I'm going to pass the string in. P is going to be the string S. I'm going to pass the string in here. So what I'm going to do is I'm going to check star P, right? P is pointing to some element of the string. Star P is the actual character. So if star P is the null character, I know I'm at the end of the string. Then I'm still going to return. But if it isn't, like right now, star P, P is going to be pointing over here, and star P is the first character, which is the H. So I'm going to print out the H, and then I'm going to call print on P plus 1. So now I'm going to call print on the rest of it. And so it's going to print H, and then E, and then L, and then L, and then O. And finally, it's going to hit this one. So it's right the null character. So then it's going to return. Where's it going to return to? Well, it called print from right over here, right? So it's going to return right before the brace, but this is a return, right? So basically, it's going to be building the activation stack, passing P, and a new P, and a new P, and a new P. And finally, when it finally gets to the null character, it's going to collapse the activation record, the activation stack. But again, what the basic idea here is that to print a string, print the first character, and then call the same function on the rest. So what does it have to do with our approach to the 8-queen program? So if you remember, how did we characterize the 8-queen problem? So we have some array, right? The array was called Q, right? Here's the array Q, and the array Q goes so 0, 1, 2, 3, 4, 5, 6, and 7. This is 5, 6, and 7. And then I had some set S. Remember, the set S is going to be the value, and this is, let's say, C tells me what column I'm in. And set S is 0, 1, 2, 3, 4, 5, 6, 7. And then I had some J telling me where I am in this set. And how did we do it? We said, okay, what we're going to do is we start at C equals 0. That tells me what element of the array Q I'm in. And I'm going to work my way through this set S. So I'm going to say, I'm going to put a 0 in Q sub 0. And then I'm going to go to my OK function. And I'm going to pass my OK function the array. What am I going to pass my array function? I'm going to pass the array function the whole array Q, right? I'm going to pass the whole array Q. And I'm going to tell the array function where I am in the array Q, right? In other words, I'm going to tell him, I just want you to look at this over here, right? I want you to look at this segment of it and tell me if there's any problem, right? And so if I succeed in doing this, then I'm going to call my function on the rest. So very, very similar to what we just did here with printing the string, right? It's a little bit more general, because with the string, once I print the position, right, let's say I print the H, then there's nothing, I never come back here. The generalization is the following. It could be that I put a 0 here and then I go off and nothing works, right? That's when I need I need backtracking, and we'll see that it automatically gets taken care of by recursion. So I might have to come back and revise what I put in a previous cell. But then once the revision happens, I'm going to just move to the rest and try to call the function on the rest. Okay, so that's a characterization of an approach that's recursive, right? I don't know how to solve for the 8 queens, but I'm going to take a stab at solving it for the first one and then try to solve it for 7 queens. And again, the only wrinkle in this is I might have to revise, but then I'm going to go back again, right? So let's see how that might work. First, let's see what we have in this program that we know about. That's not going to be a surprise. So the print function is the old print function, right? We're going to pass the print function in on array Q, and at this point, what are you going to print? Only when the whole problem has been solved. So you know exactly how big it is. You're going to be printing all the 8 elements of the array Q, and so that's it. No problem. We're also going to have the same OK function that we had before, right? And what did we pass into the OK function? We passed in where what the array was, and I is what column I'm in. And what it's going to do is it's going to go and look at column 0, 1, 2, 3, up to I, and it's going to try to see if that sub array is okay, right? And so we know about those things. The main program is going to be absolutely trivial, right? All the whole program is going to do is it's going to set up the array Q, right? Notice there's no initializations over here at all, and it's going to call the function that's going to do most of the work, and that is the function called move, right? So I pass it the array Q, and I pass it a 0, and a 0 tells me I'm right now going to be in column 0 of my board, right? And that's basically Q sub 0. Tells me where I am. So all the work is going to be done here in this function called move. So let's see how this works. So if when I come into move, right, Q is my array. That's the array that I got from the main program down here. And so if I come in here with a value of I equal to 8, well, that means I filled in columns 0 through 7. So I sort of print it and then I return. Right? So that's the easy thing, and we'll actually trace through how this thing works in a little bit. But if not, so let's see what happens. Let's trace this. Let's take a look at my array Q. So here's my array Q. Okay, here's Q, and it's going to be I, right? So so I is not 8. Let's imagine we start out here in the beginning with I equal to 0. So what happens now is, what is J going to be? So remember we had this set S, which was 0, right? 0, 1, 2, and we had J in here, right? So J was 0, 1, 2, and so on. So we're going to start with Q sub I is equal to J. J starts out at 0. I'm going to put a 0 in here, right? Now I'm going to call the OK function with Q and I. I tells me I'm in 0. So I'm going to pass my OK function basically this sub array, right? And OK is going to tell me whether it's OK or not. In other words, just the array that has a 0 in the first position, and I'm passing it the whole array Q, right? But what I'm asking it is, I'm up to column 0, and I have a 0 in here. Is this okay, right? This whole piece here is okay. Of course, the okay function is going to say yes, right? There's no problem over here. So I'm going to call move itself. Now move is the same function. Move is calling move. What is the, how am I stopping this, the recursion? What's the base case? The base case is if I've completed the whole array. In other words, when I go and I try to put something in column 8, which means I'm ready to print, right? But it's not that. Right now, when I come in here for the second time, so I is going to be 1. Is 1 equal to 8? It's not equal to 8. So when I come back here, I start J again, just like we saw this. We saw the process, but now it's happening in the program, right? The process, J is moving through the set S. So let's see what happens now. So J is equal, starts at 0 again, right? Every time I make a call to the function move, J starts at 0 again. Why is that? Well, that's equivalent. When am I moving? When am I calling move again? When I'm trying to place something in the next column, right? And then I'm going to try to place something in the next column. So that's what we did when we examined the 8 queens problem in a sort of more abstract way, right? We saw that every time we start a new column, I'm going to start a new counter J in there. Okay, so I come in here now. I is equal to 1 at this point. So J starts at 0, but I is equal to 1. Right? This is my I. So Q sub I, Q sub 1 is equal to J, and J is 0. So what happens now? I now call OK. I ask, is this configuration here OK? And the answer is, what's the OK function going to say? It's going to say no, right? It's going to say no, right? Because it's no good. So what's going to happen? So what's going to happen is it's not going to call move, because it only calls move if the OK function is correct, right? In other words, it says, if the OK function is OK, then call move, right? Right. This belongs to the if statement, right? But if not, you don't call move. You come down over here and you go back to the top of the for loop. And what happens at the top of the for loop? You get another value for J, right? In other words, you didn't leave this. You put a 1 over here, right? You put a 1 here, right? J becomes 1 because J is what's going on in this list in the for loop. And so then you send the OK function these first 2 elements of the array Q, right? The pointer to to 1, and it's going to say no good because this is on a diagonal, right? So then that doesn't work. You're not going to call move. You can come back over here to the top, and you get the next value of J, and J is going to be 2, right? And you're going to send that to the OK function. OK function is going to say OK. So then what's going to happen is you're going to call move, right? You're going to call move. So what happens when you call move, right? You call move the next value of I. So I is going to become 2, right? I is going to become 2. And again, you start with a new fresh with J. And you try 0, and you're going to try 1, and you're going to try 2, right? And you try 3. That's not going to work. And finally, you're going to try 4, and 4 is going to work. And you're going to keep going in exactly the right way, right? Exactly the right way. And you can see what's happening in terms of the activation stack. Now, again, as I pointed out, you really don't want to think like this is a programmer all the time, but I just want to show you what's really happening so you can get a little bit of a feel. So what do I have? What's the activation record going to look like? It's going to have the array Q, right? Where the array is, the pointer to the array. And what's it going to have? It's going to have the value of the parameters, which is going to be, what's the parameter to move? Every time I call move again, it's going to have an I, right? And it's going to have a J. It's going to know where I am in here, and it's going to have a return pointer, right, to where to go back when I call. So initially, Q is always going to be the same pointer Q, and I, which is where I am in the array, is going to first start with I is going to be 0, right? And then we're going to try J equals 0, and that doesn't work. And then we're going to try J equal 1, and that doesn't work. We're going to try J equals 2. We try J equals 2. So then what happens, right? I'm sorry, this does work, right? This does work. When I is equal to 0, J was equal to 0, and then we called move again, and we call move again. So it's the same array Q. I is equal to 1, and then the J starts at 0, and that doesn't work. And then J starts at 1, and that doesn't work. And then J becomes 2, and that does work, right? And the question is, at this time, where is the return? Where's the return going to be? Right? Where's the return pointer? So at the first time I call, the return pointer is going to be from where I actually called it is back to the main program, right? It's going to be back here because I called move from over here. So the first time it's going to be back to the, over here it's going to be back to the star down in the main program. But other times, where is the return pointer going to be? Well, where am I calling from? Where am I calling from? I'm calling from move over here, right? I'm calling move. So if I end up returning to move, where do I return to? I return to the statement after move, right? But there is no statement after move. It's sort of like an imaginary statement, but it's basically going to take me to the closing brace. We can call that place A, right? So after move, I'm going to go back to A. Where is that going to take me? It's going to take me back to the for loop, right? To the top of the for loop, where I'm going to get another value of J, right? But what happens if I go through the whole for loop? And we'll see that in a moment, right? But so then what's going to happen after this? It's going to be another call. It's the same queue. It's going to be column 2, and this is going to try a 0 and a 1 and a 2 and a 3 and a 4, and so on. The return point is always going to be back to A, right? Always back to A. And where is A? A is going to take me again to the bottom of the loop, right? And what's going to happen finally? What's going to happen finally? So what did we have? Remember back to where we did this. We have 0, 2, 4. What's the next one? I think there was a 1 over here. And what was after that? Maybe a 3. I don't know. Something like that, right? But when we turned out, I don't remember what we had. But what happens is when we try 5, right? So we're going to be all the way up here. We're going to try 5. It's going to be the same queue, right? And whatever value we have, it's the 2 is going to be, the value of I is going to be 5, because I'm trying to put something in the 5th one. I think that's the one that fails, whichever one fails. And what's going to happen here is I'm going to try all the J's. I'm going to try is equal, and this we've seen multiple times. I'm going to try J equals 0, 1, 2, 3, 4, 5. Each time I find myself in this loop, right? I find myself in the loop, and I find J equals 0, that doesn't work. J equals 1 doesn't work. 2, 3, 4. Finally, J becomes 8, right? What happens when J becomes 8? When J becomes 8, I finished the for loop, right? So I come out of the for loop and I find myself over here, right? And what happens? What happens when I find myself over here? Well, I'm just going to return. There's an implicit return, right? And where am I going to return to? I return to wherever I was called from, right? So in other words, there was an A over here because I was called from move. So I'm going to come back to move. But what's going to really happen? The activation stack is going to shrink. But in fact, over here, what's going to happen is I couldn't put anything in row 5, in column 5. Again, if that's where it was, where we worked on this previously. So what's going to happen is when I go back, it's going to take me to the previous activation record. What's that going to give me? That's going to give me a different I. So that's where, notice there's no explicit call on a backtrack, but the backtrack happens automatically, right? Once this for loop fails, I'm going to be at the bottom of the move function. There's an implicit return over here. So I'm going to come back. I'm going to go back to whoever called me. Who called me? Who called me was move on the previous level of the activation stack, right? So that's the way this thing works. It's really straightforward. Let's just make sure it's clear again, right? So, and this is exactly what we've been doing, right? Every time I call move, I'm essentially moving to the next column. But instead of doing it with an iteration, right? And we said C++, C++. What's the equivalent of C++? What's going to the next column? Basically the call on move. Because when I say I plus 1, I represents the column. So it means I'm going to go try to put something in the next column. So this is equivalent when we wrote the whole thing in terms of loops, either with a goto or explicitly with some other looping mechanism or by calling functions. We move to the next column. What the equivalent here is the call on move. What's the equivalent of the backtrack? When we couldn't, what's the equivalent of trying to put something in the given column? Well, that's this for loop over here. Try putting a 0 in the column, a 1 in the column, a 2 in the column. In column I, try putting a 0 and a 1 and a 2, and that, keep doing it. Each time, go to the OK function, which is what we did whenever we wrote the programs. It was always a call in the OK function. right? And if this completely fails, right, if you can't put anything that's going to work, you just finish with the call on move, and then you end up backtracking automatically, because you're going to go back to where you came from, and it's automatically saved for you, right, on the activation stack, all the previous values. Well, Q is always going to be the same, but when you come back, I will go down by 1. That'll tell you what column you're in, and J will tell you where you were, right? J will tell you where you were. So, for example, let's say when I finally get to column 4, to column 5, again, let's assume this is the way it works. So the value of J on the previous call is 3, say, for example. So then I try 0 and a 1 and a 2 and a 3, and nothing works. I'm going to come back over here, but when I come back, it's going to be at the previous level of the activation record, and that's going to keep the J that I had before. So when I come back, where am I going to come back into? When I come back, since I called from move, as we saw, when I come back, I'm always going to go back to point A. When I come back to point A, and the previous level, right, when I come back from a move that didn't work, right, that for the next column it didn't work, I'm going to come back into the loop, but I'm not going to start at the beginning of the loop, right? I'm going to always come back to whatever J happened to be. So in this case, if I can't place anything in column 5, when I come back to column 4, I'm going to come back over here, right? Because if it didn't work, I was trying for every value. When I come back in the previous one, I'm going to go to top over here, right, back to the for loop, but I'm going to pick up the value of J, right? Because how do I know what the value of J is? It's stored under J, right? And that is the way that it works. This is, you see, it's a very nice approach. It's similar to what I showed you over here with the string. The only difference is with the string, as we saw, once I print an H, I just move. There's nothing else to do until I'm finished. Here, it's always tentative. I try a 0, and if it works, then I just do the rest. If it doesn't work, because I can't, like this column doesn't work, so I tried this piece. If that doesn't work, I'm forced to come back and then modify it, but then I'm going to go back this way as well, right? So that is how you do the 8 queens recursively. And I just want you to look see how really clean this whole thing is. Right, so just take a look at how simple this thing is. Everything happens in the move function, right? And the move function is recursive, is the base case, right? So this says if we're finished, then just return. You do what you need to do, print it out and return. Otherwise, you're in column I, try to place a queen in column I. If it's okay, then move to the next column. If the current value of J that you're trying to put in there, 0, 1, 2, if that doesn't work, then try the next value, the next value, the next value. If you find one that works, then you call move. If you don't find one that works, come out of the for loop and then return from the move function, which essentially takes you back to the previous activation record, which in fact, as we've been analyzing the whole thing from the beginning of the semester, it takes you back to the previous column, in which case you try to pick up from where you were, right? Because you're going to have a copy of J on the activation record right below the one you came back from, and it's going to take care of it automatically. It's a very, very simple, once you understand what's going on, it's a very simple approach. Not only that, this gives us sort of a template, an approach to how to solve all those problems that we looked at. So for example, if we wanted to look at, let's say, the 8 numbers in the cross, right? Would this work for the 8 numbers in the cross? Absolutely, right? All you'd have to do is you have to change the OK function. It's exactly what we did before, because you solved the previous one using, the engine that you wrote for the 8 queen, but you changed what? You changed how the OK function worked, right? Because every time you try to put another value in there, you check to see whether it was okay with respect to the squares that were adjacent to you, right? But that goes into the OK function, so the whole thing is modular, right? You would put, for the OK function, would change that. The print would stay the same. The move would stay the same, right? You would be putting some value in here. But here Q would represent which block in the cross you're in, and J represents the value that you're putting in there, and it'll call the OK function if you find that it's okay, the value, the J you want to put into the ith block on the cross, then you simply move on to try to put something In the next one, it's exactly the same. But you look at the control structure is laid bare over here, and it's very, very clear to see. Likewise, if you wanted to solve the stable marriage problem, it's the same thing, right? Same thing. The OK function would be the OK function for stable marriage, and what would how many would how big would the array Q be? Well, so the array Q would be as many couples that you have. If you have 3 men and 3 women, so you would change the size of the array to 3, and the guts of the move function would stay the same, right? Because that's the engine. Remember, we have that same array Q, right? And we have that set S, right? The set S, and it's just that the OK function is going to change. So anytime you have a problem that's equivalent to saying my solution is going to be a sequence of values, so that I can test each time as I'm building the sequence whether the subsequence that I've built so far is okay, doesn't violate whatever the rule of constructing the sequence is, you can use this approach. You can take this program, and all you do is plug in the criteria for the OK function, make sure the array that you're printing is the appropriate size, and the move is basically the same move, except you'd have to change maybe the 8, whatever, but the rest of it is the same, right? This is a really powerful idea. I hope it makes sense. If it doesn't, go back and listen to it again, and then we're going to try some examples based on this.